Today, which is Monday, October 9th, we're starting section 3.1, which is graphing relationships. We will cover 4 learning targets in this new unit, but today we are going to be focusing on learning targets 10 and 11. Learning target 10 is interpreting and relating graphs to events, and we will do a part of learning target 11, describing relations and functions using accurate vocabulary. Today we will talk about domain and range. Okay, so on your notes page, you'll notice at the top you see interpreting graphs. Let's go ahead and take a look at the graph and we'll read what this graph is describing. This graph is describing the distance a delivery van from a warehouse varies throughout the day. The graph shows the distance from the warehouse for a day from 8 a.m. to 5 p.m. So right around here would be 8 a.m. and this would be 5 p.m. Let's assume that this delivery van is delivering furniture. The first question says that segment 1 shows that the delivery van moved away from the warehouse. Notice that in segment 1 that the distance is increasing. Question, what does segment 2 show? Well, as I take a look at segment 2, I notice that the distance is still increasing, but the slope is not as steep. So what does that mean? Well, that means that the delivery van is still moving away from the warehouse, but it is moving at a slower rate or a slower speed than it was in segment 1. The second question about this graph, based on the time frame, what change in the distance from the warehouse is represented by segment 6? So what I notice about segment 6, and segment 6 is right here, is that it looks like it's about halfway through the day. Okay. I also notice that the distance, because the distance is what's represented on the y-axis, the distance is decreasing. So what change does that mean? That means that the delivery van is driving towards the warehouse. The third question asks, which line segment shows intervals where the distance does not change? So segments where the distance does not change would be segments 3, 5, and 7. The distance is not changing. That means that the van is not moving away from or towards the warehouse. So what would be a possible explanation for those segments? Since the distance is not changing, that means the delivery van is stopped. It could be delivering furniture or dropping off furniture at different homes. Another option would be that it could be the delivery van could be stopped for someone to eat lunch or stopped at a really long stoplight. Okay, let's take a look at the second part of your notes, which is relating graphs to situations. All 3 graphs are showing you and a friend playing catch. You throw 3 different balls to your friend. Describe a situation that could be modeled by each of the 3 graphs. So I want to take note of what is represented on the x-axis, which is time in seconds, and on the y-axis, which is height in feet. So with the first graph, I notice that the ball is released and the height of the ball seems to stay pretty steady, and then it drops and it looks like it's rolling. So how could I describe what happened? Okay, I would describe that as I'm releasing the ball at waist level. The ball is traveling at waist level for a short time. My friend completely misses and doesn't catch the ball, and it hits the ground and it rolls. Let's take a look at the second graph. With the second graph, the height increases, okay, and then it begins to decrease, it begins to come down, and then the ball stays. So what that is representing is that I probably threw the ball underhand, okay, maybe I released it around waist level, the ball travels up, hits a maximum height, and then it begins to travel back down. My friend catches it at about the same level that I threw it at. Okay, with the third graph, I release the ball and the height increases, and then the height stays the same. So what's a situation, okay, that could be described by this graph? I probably didn't throw it underhand because it didn't come up and go up and come back down. I probably released the ball throwing overhand around shoulder level. The ball travels upwards slightly, and my friend jumps up and catches it while it's still at its highest level. Okay, so now we've looked at interpreting a graph, relating graphs to situations. Now we're going to go through some vocabulary terms. On your note sheet, you should see 4 vocabulary terms for continuous, discrete, domain, and range. Keep in mind at any point, if you need to pause the video to write things down, make sure that you do that. Okay. First of all, a continuous graph is a graph that is made up of connected lines or curves. Both of the graphs that we've looked at are examples of continuous graphs. Second vocabulary term, discrete. Discrete is the opposite of continuous. It is a graph that is made up of unconnected points, and we will talk about what an example of that is in one of our next couple of examples. Okay, the domain is all possible input or x values. The domain will always be represented by the x-axis. And the range would be all the possible output or y values. The range values we will see along the y-axis or the vertical axis. Okay, the last 2 examples are sketching graphs for situations. Okay, so our first example says at the start of a snowstorm, it snowed 2 inches an hour for 2 hours. Then it slowed to 1 inch an hour for an additional hour before stopping. 3 hours after the snow stopped, it began to melt at 1/2 an inch an hour for 2 hours. So what I'd like to do is we're going to plot some points, and then we will determine whether this is continuous or discrete. So we know that it snowed 2 inches an hour for 2 hours. So after 1 hour, it had snowed 2 inches. That would be 2 inches per hour. Okay, and it snowed at 2 inches per hour for 2 hours. So after 2 hours, there are 4 inches of snow. It says then that the snow slowed to 1 inch an hour for an additional hour. So in the next hour, so now we're at 3 hours, it snowed 1 additional inch. So now we're at 5 inches of snow. Okay, nothing happens then for 3 hours. So for 3 hours, nothing happens. And so at the beginning of hour 6, we still have 5 inches of snow on the ground. But after 3 hours, it begins to melt at 1/2 an inch for an hour for 2 hours. So between hour 6 and hour 8, and hour 8 is actually not even on the graph, it would have to be over here, we would lose 1/2 of an inch per hour. So we would lose 1/2 an inch by hour 7 and 1 full inch. So we're down to 4 inches by hour 8. What I like to do is plot points and then go in and graph the points. So is this graph continuous or is it discrete? Continuous means that it is ongoing. And as we look at our x, what x is represented by, which is also the domain values, it's time. Time must continue. There's no way that time can stand still or that it would be that it would stop. So because it is continuous, our graph will also be continuous. So I'm going to connect these points. We can see that between hours 2 and 3, it's still snowing, but at a slower rate because the slope is not as steep. Between hours 3 and 6, there is no snowing, but there's also no melting, so the height of the snow stayed the same. And then from hours 6 to 8, the snow began to melt. So what is the domain? Well, the domain for this particular function would be 0 to 5 hours. Actually, we should say 0 to 8 hours. I'm going to correct that. Okay, this story is represented, okay, by hours 0 through 8. So the domain of this scenario is 0 to 8 hours. What is the range? Well, the range would be the total inches, or the inches of snow. And notice that we started out with 0 inches of snow all the way to 5 inches of snow. So all possible values of snowfall is 0 to 5 inches. Okay, and our last example is the Stampede example. The Stampede, our school store, is selling Spirit t-shirts for $10 each. The store has 50 t-shirts to sell. Okay, so we have to determine what would be labeled along the x-axis, and that would be the number of t-shirts. And the revenue, the amount of money taken in, would be along the y-axis. So I notice that I have 1, 2, 3, 4, really 5 spaces. Okay, and I know that I have 50 shirts to sell. So I want to use all of that space. So if I have 50 shirts divided by 5 spaces, that means I need to number my x-axis by tens. So 10 shirts, 20 shirts, 30, 40, and 50 t-shirts. Okay, the y-axis represents the revenue that the school store has taken in. Each shirt is being sold for $10 each. That means that they could take in a total of 10 times 50, or $500. When I count all of the tick marks on the y-axis, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 tick marks or grid lines, and I could sell up to $500. So I'm going to take 500 divided by 10 and let each of those grid lines represent $50. Okay. All right, so please go ahead and number your graph as well. Okay, so I am not going to plot every single point, but just like we did with the snowfall problem, I'm going to mark some points. So if I sell 10 t-shirts at $10 each, then I know that I will have sold $100 worth of shirts. If I sell 20 t-shirts at $10 each, okay, I've brought in $200. 30 t-shirts brings in $300. 40 t-shirts brings in $400. And if I sell all 50 t-shirts, then I am at $500. Is this function continuous or discrete? Well, this function is actually discrete. And the reason why is that the number of t-shirts is not continuous. I cannot sell 1.5 t-shirts or 42.5 t-shirts. No one is going to buy a part of a t-shirt. So I do not want to connect with a solid line. I would actually be connecting, because I could sell one t-shirt, okay, for $10, two t-shirts for $20, three for $30, four for $40, five for $50. My points are not are spread out very accurately. I could sell 15 t-shirts for $150, 25 t-shirts for $250. And I can have a lot of points in here, but each of these points is representing a whole number of t-shirts, because I cannot have a part of a t-shirt. That said, the domain, which is the total number of t-shirts, all of the values for t-shirts, I could sell as few as 0 t-shirts or as many as 50 t-shirts. So my domain is 0 to 50 t-shirts. And the range would be the all possible values for Y, which is the revenue. So I could sell as little as $0 or as much as $500. So the range is $0 to $500. Okay, if there's any part of the video that you need to go back to fill in your notes, please do so. But once you have completed your notes, go ahead and show your teacher, and you will have a review assignment for tonight, and then tomorrow during class you will actually do the book work based on your notes for today. Have a great day. Thanks a lot. Bye-bye.